When using a large language model, there might be a need to add some additional context to it. It might be some domain-specific knowledge on which the model was not trained on, or maybe the real-time context such as traffic information, weather, or latest market fluctuations, or maybe some user-specific details that you for sure wouldn't want to use to train that model. And whatever reason you have, the approach of combining the powers of a large language model with some additional storage with extra context is called retrieval augmented generation. And we do have a variety of different technologies to work with that. However, the most popular framework by far right now is called LangChain. And in this video, I would like to show you how to use the LangChain JavaScript library to combine the powers of a large language model, and I will use Amazon Bedrock with Cloud model with some external storage where we can store the vectorized information, and I will be using OpenSearch for that. So without further ado, let's dive in and let's create a small project. And to give you an idea of what I have in mind, I would like to create some kind of memory service. And this service will have two methods. First will be to store a memory, and it will accept some kind of memory there. And the second one will be to get relevant memory based on some kind of request, or we can call it a query. To implement those, we will have a large language model which will be able to behave like a chatbot to answer our questions, so that we can give it a query and ask about some information. However, with that, we will also have a separate storage with the information which we will provide through the store memory, and we will give some kind of a memory, some ideas to that storage, and we will store that information there. And then when the large language model will get the query, it will take its knowledge combined with external additional memories that we provided before, and will return us some kind of an answer. For that, we will need a bunch of different libraries. So let's install those. And I have the list over here. So we will need a LangChain for AWS, LangChain Community, LangChain Core, LangChain, a lot of those. Then we are going to work with OpenSearch. So we will also use OpenSearch project OpenSearch library. And finally, to work with Bedrock so that we can send our queries to Bedrock, to the models which are part of the Bedrock stuff at AWS. We will also need the client Bedrock runtime. So let's install those. By the way, the code with the repository and code snippets and everything else you can find in the description section below. To see all the installed stuff, you can go to package.json. This is the libraries which we have right now, and with that we can go back to our service and start implementing it. And to use LangChain capabilities, we will have to do a bunch of different steps. The first one would be to specify which large language model we are going to use. This will be Bedrock Cloud model for me. So in Amazon Bedrock Service Console, you will need to enable the access to that model. So I'm going to use Cloud Haiku. You can also get some examples, or if I would go to overview and here I will select Cloud. There were quite a bunch of useful stuff here when we have the description of that model, because I used, for example, the API request as an example for the stuff I wanted to send to see what is the format of that request. So you will need this particular model or another one if you want to use a different one, even though if you're going to use different one, the response structure might be different. So you will have to fix that. Then we will also use an embedding model. We need an embedding model to translate all the new memories which we are going to store in our external storage in OpenSearch into vectors. And if you are not familiar with vector search or with semantic search, we can transform all kind of information into vectors which will be positioned somewhere on a multi-dimensional space, and then later when model will have to retrieve those memories, it will be able to reference them by the vectors positions to find the most relevant stuff to our request. So for the embeddings model to translate the text we provide into vectors, we are going to use a different model. There is this Titan embeddings G1. So this is the one which I'm going to use for that. You need to enable it as well. Then we will need to have OpenSearch. We are going to create an OpenSearch store. For that, I am using Ivan for OpenSearch. I work at Ivan. I like our platform. So I'm going to use that one. Of course, you can run your OpenSearch service whenever you want, or you can also use Ivan service for that. The link in the description if you want to create that one. Then we are going to connect OpenSearch store with the embedding model so that LangChain can work with them together. And this will create a vector store. And then we combine the large language model with this vector store to get the chain, and you will see how it works. So let's do it one by one. And while I haven't forgotten, we will need, of course, credentials to access our AWS stuff and our OpenSearch stuff. So for this, I will add an environment file, and I will provide the information about the OpenSearch URI, which I will get, for example, over here. Then the same for the AWS Access Key ID and Access Key, which you should get from your user in the AWS console. And to make sure that the values from the .env file get into the process environment variables, I'm going to install the .env library. And now in the memory service, we are going to import .env and run .env config. And this will do all the gluing magic there. For the large language model, we are going to use an instance of Bedrock chat, which I will include. I believe we don't really need this part. So we are going to tell which model will be behind the Bedrock chat, and this is the model which I have enabled. And you can get those examples whenever you're going to the model information, and like a lot of stuff you can find in the available examples on this web page, which is very, very helpful. Okay, this is Sonnet, but we are going to use a haiku. So this is the one which we are using. Then we need to tell which region we are having it from. This is quite important because not all models are available in all regions, but you can check the AWS documentation for that particular stuff. And finally, the credentials. This is the stuff which I stored in my .env file, and here I am referencing it by the process env and then the values which I have to access my AWS account. For the embeddings model, I use the instance of Bedrock embeddings. We can also include it from, this is actually goes from the LangChain. And here I provide similar information, the regions, the model, and the credentials. Then we need to create an OpenSearch store. For the OpenSearch store, I'm going to rely on the client, which is actually coming from the OpenSearch library. So let me see, it will be OpenSearch project OpenSearch from over here. And we need to provide the OpenSearch service URI so that the client knows where to connect to. And we also need to specify the index where the information will be stored in. So for that, because we are also going to use that index later in the functionality, let's include it as a part of the constructor when we create our memory service, so that we specify also the index name. It can be anything technically because OpenSearch can create those indexes on the fly. So this index name will be equal to index name which we will provide. This leaves us with the vector store which comes from the LangChain library as well. And I don't think that we really need this stuff there. But let's see if we will have any errors later for those dependencies. And to combine the vector store together with the large language model, we are going to use this construction where we are creating a chain and we provide information about the large language model, about the vector store, and also some additional stuff, return source documents. I'm not sure what it means, but I guess these are very, very important properties. With that, we can now move to the storing memories function. Whenever we have a new memory that we want to remember, we need to do these two steps. First of all, we will need to package that memory in a document because OpenSearch works with the data which is represented by documents. And secondly, we will need to translate that information into a vector representation for that document and then index it, or in other words, to store it in our OpenSearch index. Here we rely on the OpenSearch vector store, which again comes from the LangChain, and we run the method from documents, which takes a list of documents. We do have only one here, but you can include numerous. And then we provide, we say which embeddings model we want to use it to encode it into a vector, and then where exactly we are going to store it, and the OpenSearch store, which we have over here, has information about where to connect, as well as the index name is where to store the data within the OpenSearch. And to get the relevant information from our OpenSearch plus our model, we are going to use the chain which we have created over here. And we will call it with some given query, which will be just a text about some information we are interested in, and we will respond with some kind of a text. So this is the module itself. We will still need to run it to see if we have any issues which we will have to fix, but we can create some kind of run.js files to start using that module. I'll call our index memories. So I want to store a memory that Dora is a German Shepherd who lives with Bob. I don't think that any large language model really has this whole idea. And then we are going to ask who is Dora, and we are going to console log the response. Let's see if that will work. Not surprisingly. Okay, as model, we need to have type module. I forgot to add it to the package JSON, so that will go over here. Let's try again. Cannot find module memory service JS. That will go into the run over here. One more time. Is not defined. That will go from the LangChain chains. So we can add the dependency over here. One more time. Okay, never ending errors. Document comes from the LangChain document. And based on the context provided, Dora is a German Shepherd dog who lives with a person named Bob. And we can check what exactly got stored in OpenSearch through the OpenSearch dashboards. And here we have just one item with the information about the text. Dora is a German Shepherd who lives with Bob, and the embedding which we got from the embeddings model. So this is how it works, and this is how you can use LangChain with JavaScript to combine the power of a large language model together with a vector store OpenSearch.